Assalamualaikum warahmatullahi wabarakatuh to Encik Mazri bin Ibrahim and Encik Arman Hadi bin Azhar. My name is Muhaimin bin Saari from BEI section 1/2 and my supervisor is Encik Asri bin Din, and today I would like to present my PSM project. My project is referred to degradation monitoring of high voltage polymer insulator using a stretch leakage current signal parameter. And this is my poster. This poster consists 5 parts, which is first, introduction of this project research. Second, objective in this research that need to achieve. Third, methodology where method that used to collect the parameter needed. Fourth, the result and discussion where the data were analyzed for 2 field edge insulator. And the last one is conclusion for the overall result achievement and recommendation. So basically this project is about doing condition monitoring of field edge polymer insulator by analyzing the parameter involved, which is surface roughness and two-dimensional mean, to determine the degradation condition of polymer insulator for 6-year and 80-year field edge. Okay, for the introduction, the demanding electricity to consumer has increased eventually using high voltage transmission network. The component that being used in transmission systems such as insulator, transformer and so on. This component is important part by transmit electricity to consumer effectively. In order to provide excellent performance for aspect transmit, the equipment need to be preserved, which is insulator. Nowadays, polymer insulator is commonly used as outdoor insulator, such as easy to install and has special feature of hydrophobicity. However, polymer insulator tend to degrade cause of exposed to various stress during operation. The stress would be mechanical stress and electrical stress, which can affect the physical of insulator. So, to overcome this degradation effect by analyzing in physical state, which is surface roughness, and the electrical signal, which is two-dimensional mean leakage current. For the problem statement, polymer insulator needs to well made, and if not, it can accelerate the degradation of insulator due to various stress which experienced by outdoor insulator. It can lead to weight loss, erosion, surface cracking, and lost hydrophobicity, and many more. The various stress can affect by physical state, and dielectric performance insulator will be reduced as well. Besides, to determine the surface performance by study on leakage current parameter. In this case, short-time Fourier transform will be used to extract feature which is two-dimensional mean in spectrogram and collect the data two-dimensional mean to analyze signal behavior for two field edge insulator. Overall, these two parameters such as surface roughness and two-dimensional mean leakage current would be indicator to performance and strength of degradation insulator. Then, the objective of this project research is first to investigate the physical evaluation performance of polymer insulator, which is surface roughness. Second, to statistically gather the two-dimensional mean of spectrogram for 6-year and 80-year insulator. And the third is to compare the degradation performance between 6-year and 80-year insulator using the surface roughness and leakage current parameter. The methodology of this project research only consists of software component due to unavailable for doing laboratory testing. There is two types of software that being used to gather or collect the data of parameter, which is LabVIEW to store the all data surface roughness, and MATLAB used to analyze two-dimensional mean leakage current in spectrogram. Figure 1 shows the flowchart for this research methodology, and the data will be analyzed by comparing two types of insulator, which is 6 years and 80 years. And at the data collection, where the data being analyzed by implementing LabVIEW and MATLAB software, then compare between two types of field edge insulator. If the data can be compared between insulator, it will go through the data analysis. At the data analysis, if the data can give different degradation performance, it will proceed to the result and discussion. While if no, it will go to the literature review to make sure the information of the data analysis is valid and compared to previous research. For the result and discussion, the data have been collected from the software implementation, and since the testing is not available for data analysis, so I use the data that have been provided. The data which provided is surface roughness, while two-dimensional mean analyzed by using MATLAB software. Figure 2 shows the two different performance based on the mean arithmetic surface roughness of number of shield insulator for two type of field edge. Based on the bar graph, the value of arithmetic mean surface roughness for 80 years is much larger compared to 6 years, and it can observe the trend of variation mean arithmetic surface roughness for 10 sample field edge of 6 year and 80 year is same pattern. However, the value of mean arithmetic surface roughness for 80 year is bit higher rather than 6 year. Figure 3 refers to two different performance based on the average two-dimensional mean leakage current of number sheet insulator for two groups of field edge. From bar graph shows that the value of average two-dimensional mean for 80 years is much higher than 6 years. This is because the insulator for 80 years has experienced a longer period of field service. Based on the 11 samples of both field edge, the trend of variation average of two-dimensional mean leakage current of 6 years and 80 years is not same pattern, but the value of 80 years is bit higher than 6 years. Figure 4 represents the time frequency representation leakage current in spectrogram for different value of two-dimensional mean field edge insulator. 6/20 is referred to 6 years and 80/20 is referred to 80 years. For the aspect visualized of energy signal, it can be seen the presence of energy signal on time frequency domain located at 15 Hz. This is because the electrical power source that been applied to insulator using IPT test is 3.5 kV with 15 Hz frequency. It shows the energy obtained in the sample 80 year more higher, which represent in orange color tone compared to sample 6 years. Therefore, the signal energy can be illustrated by color intensity legend, whereby the energy increase as the response to increasing value of two-dimensional mean. Table 1 shows the average value of two-dimensional mean with the surface roughness. From the observation, it seems the electrical signal is correlated with surface roughness, where the Ra increase and 2D also increase. It can prove through the field edge sample 2, 3, 15 and 20 sample. For the sample 2, the average value of Ra for 6 years is 0.897 micrometer. Then for the value of Ra for 80 years is 1.61 micrometer. Meanwhile, the average value of M2D for 6 years is 2237 nano energy unit, and the average value of M2D for 80 years is 2893 nano energy unit. The value of two-dimensional mean in nano which not give specific unit because electrical data that have been collected by using statistical value of the spectrogram. The value that we get is represent the quantity energy that contained in the signal. In conclusion, the objective of this research achieved successfully whereby the parameter of the Ra and M2D correlate each other between 6-year and 80-year field age. However, according on the overall result of leakage current is still not enough to prove the level degradation of polymer. For the future recommendation to improve the result is by increasing the number of sample polymer insulator between 6-year and 80-year field age. Besides, by using MATLAB software able to analyze the presence of energy signal based on the Ra and M2D by time frequency representation in spectrogram. Okay, that's all my presentation for today. Thank you.